Hi everyone, welcome to my channel for the engineering, software engineering and cybersecurity, cloud computing, etc. etc. So today's topic is very interesting, which is basically fog computing. Fog computing. So what is fog computing? Fog computing is one of the kind of edge locations computing, where we are putting the cloud computing devices or the data centers, you can say the edge data centers, to the closer to the endpoints. So our endpoints, which are our endpoints, are basically traffic signal, then cars, then routers, then mobile phones, laptops, and various other things, maybe drone. This is okay. So why fog compute is required? So in IoT environment, IoT is nothing but the Internet of Things. So Internet of Things environment, we need to collect the data from the various appliances and various locations, and then want to process those data very quickly and efficiently. Here we want to reduce the time, we want to reduce latency of processing the data. Why we didn't want to reduce latency? Because of faster processing time. So this is overall the high level understanding of fog computing. So why fog computing? I will just draw a small picture. So earlier, suppose this is cloud data center. This is cloud data center, and then we have a client over here. A client may be anything, any IoT device is a client. So any IoT devices, that is Internet of Things sensors and all, where it can capture the data and send it to the cloud, and response comes from the cloud, and maybe the response needs to be go to any action center, you can say action, where actions can be taken. Action may be fire brigade, and then we can have hospitals, then we can have police stations. So I think this is the traditional architecture. Now we want to keep a layer of the computing devices, that is called fog. Fog. So fog is nothing but edge location computing devices, edge locations. So why we need the edge locations? We just want to increase the response. We want to increase the efficiency of the response. That means reducing the response time. So suppose I will take a scenario. First scenario is Internet of Things. So suppose you have installed Internet of Things in your car, and you want to get a first response that the car is being stolen. So that response time should be fast. It will come to your device, and you can take action. You can call to the police, or you can call to the respective security agency to get help. Second thing is smart cities. So why we need the fog computing in smart cities? Because suppose in traffic signals we have the sensors, IoT sensors are installed, and there is a accident happening or traffic jam happening. So immediately the additional control will be reached to the respective traffic center, so that they can take the action. And as the fog computing is nearer to the cloud, to the nearer to the edge devices, like nodes, related nodes, so it can process the information faster and give the response. So similarly, industrial internet of things, IIoT. So suppose one machine is running in a factory, and we have IoT sensors involved, and it is basically collecting data, and there is a machine learning algorithm running behind it, and it is basically predicting the hazards or any kind of maintenance requirement or something. So the response time should be faster. So here overall objective of the fog computing is to reduce the latency, and response time should be fast. Similarly, edge analysis. So for computing facilities, edge analytics by running data analytics and machine learning algorithms closer to the data source. So we are bringing the computing power close to the data source. This approach minimizes the need to send the large volume of data to the cloud for analysis. So we are not gathering the data in a large volume and sending to the cloud. What we are doing, we are bringing in the computing capability through fog computing to the source. So we are basically, if we just want to draw again, we are basically here is a fog, and here is our device. So anything is being captured here, the processing should be done here, and response should be very fast and sent to the suppose the response will be sent to the hospital for action. So it will send. So So response can be sent to the police stations or any kind of emergency center. Then connected vehicles, if we take example of connected vehicles running in the road, so in a long highways, vehicle to vehicle support is very much required, so they can send signals, and they can even track the other their co-vehicles are coming properly or not. They are miles away, but if there is any problem they face, then at least they can reach out to them, or they can call to the respective center for their help. So any kind of accidents scenario, it can be very helpful. Similarly, for virtual reality scenario, when we create the virtual reality, there are a lot of image processing and data processing happens, and the response time here also is required very fast. So remote for applications like gaming, remote collaborations, where we are collaborating remotely, and we are giving training remotely with mainly multiple geos. There we need this kind of fog computing to reduce the latency. So these are the overall, you can say, the applications. One is Internet of Things, second thing is smart cities, third thing is the industrial Internet of Things, then edge analysis, connected vehicles, augmented reality. So these are various examples of fog computing. Hope you like this. In case if you need any kind of extended video or any questions coming up to your mind, you can put into the comment section. I'll surely reply, and hope you all will be liking this. If you have any further requirement to this kind of videos, I will surely bring it up. And thanks for watching. I hope you will like and share and subscribe also my channel. Thanks a lot.